Hello everyone, welcome back. I hope everyone is doing great. My name is Raviteja. Let's solve today's Leetcode problem 3296 minimum number of seconds to make mountain height 0. You are given an integer mountain height denoting the height of a mountain. You are also given an integer array worker times representing the worker times of the workers in seconds. The workers work simultaneously to reduce the height of the mountain. For worker I to decrease the mountain height by x, it takes worker times I plus this particular value in seconds. For example, to reduce the height of a mountain by 1, it takes worker times I seconds. If we want to reduce the mountain height by 2, then it takes this much time, okay, and so on and so forth. Return the minimum integer representing the minimum number of seconds required for the workers to make height of a mountain as 0. Okay, the one key point is all the workers are working simultaneously. Okay, let's say I'm standing at time t. Okay, let's say t time is already elapsed and worker 1 would have reduced certain height of a mountain. Let's say this is the height the worker 1 has reduced. Worker 2 has reduced, let's say, this much height, and worker 3 has reduced this much height. Okay, if I go to t plus 1 second, either all of these workers would have remained the same or would have reduced the heights by some extra delta. Okay, when will it remain same? Okay, if all the workers, let's say if all the values are 2, that means he can only reduce the height by 1 in at least 2 seconds, right? So in 1 second he won't be able to reduce. At least he requires 2 seconds to reduce the height by 1, right? So if all the values are greater than 2, that means in t plus 1 no worker will reduce anything. So if all the values are 1, that means all the workers will be able to reduce the height by certain amount. Okay, so the bottom line is basically either at t plus 1, either they can reduce the height by some extra delta or they won't reduce, but the height reduced so far will not decrease, right? At any given point, okay, the heights reduced as time progresses, height reduced will be in non-decreasing order, right? Okay, as time progresses, height reduced will be in non-decreasing order. Okay, that means let's say t is the time at which he was already reduced certain height. Okay, that means let's say at t equal to t, the time t equal to t, let's say he has already reduced x amount of height. Okay, all the workers have reduced x amount of height, right? So at t equal to t plus 1, for sure all the workers will be able to reduce x amount of height, right? And they will be able to increase they will be able to reduce some more height, right? So if they were able to reduce height x at t equal to t, they will definitely for sure able to reduce height x at t plus 1, right? So we have to find a t such that they have to reduce the overall height of a mountain. Okay, the smallest time t such that where h is the height of a mountain. Okay, if we have to find the smallest t such that they can reduce the entire mountain. Okay, if they were able to reduce at this particular time t, they will also be able to reduce at this particular time t. Okay, so if you see there is a non-decreasing order, that means the time t, okay, time t is in non-decreasing order. Okay, and that will signal us that we have to use binary search over here. Okay, we have to do binary search on time t. Okay, if he was able to reduce the mountain height at time t, that means he will also able to reduce the mountain height at t plus 1 and so on and so forth. Okay, all the conditions will valid true, right? At e plus 1 will be true, t plus 2 will be true, and so on and so forth. Everything will be true, and all the cases before t he will not be able to reduce. Okay, so this is the starting point. T is the starting point from which he will be able to reduce the mountains for sure. Okay, so idea is to identify this time T. Okay, now in order to apply binary search we need to have a range, right? So we should be able to determine the range. Okay, so the minimum time, okay, minimum time, if you see the workers time is in between 1 and 10 power 6. Okay, so the lower limit is for sure 1, but we have to determine the higher limit, right? If you look at this example will give you to determine the upper limit. Okay, if you see there is only one worker and he has to reduce the height by 5, right? So if since he is alone he has to spend this much amount of time to reduce, right? So how can I get the upper limit of time? Okay, so if he alone works, okay, so if he alone works the time taken will be the summation of all these things. Okay, if you keenly observe I can take worker times 0 common from all of these things, then it will reduce to 1 plus 2 plus 3 plus so on up to 5. Okay, so I can rewrite, let's say this is t times of 0. Okay, so just for better readability or for me to type easily. Okay, so I can say this is the sum of the first n natural numbers till this particular 5, where 5 is basically the mountain height, right? Since I have to reduce the overall mountain height I have to spend this much amount of uh, time like for till then. So it will be like, let's say the mountain height here is h. Okay, where h is equal to 5. So it will be sum of the first n natural numbers n into n plus 1 divided by 2. Okay, so this will give me the upper limit if this worker alone tries to work. Okay, if let's say there is another worker, okay, and I should also identify the upper limit if he alone works, right? So the upper limit will be the maximum of time taken by each individual worker. Okay, so if I want to, this will give me the overall time taken for me. Okay, so this will determine the upper limit. So I just defined certain variables. Now that you understood the core logic to apply the binary search, I will just walk you through the code once. Okay, I just renamed the mountain's height with h and workers times with times. Okay, so don't get confused with it. So I just defined h as the mountain height and n is the total number of workers I have, and this is the times array. I just defined it at a class level so that I can access it in rest of my functions. I just set all these at the class level. Now as I mentioned, the upper limit is basically the the current worker time times the h times h plus 1 divided by 2. So instead of me computing each and every time, I just defined a variable called factor, which will already computing this particular value and storing it, and for each particular worker I will just multiply it and I will get the maximum out of all those things. Okay, now that I define the range of my binaries as left and right. Okay, now the idea is to minimize the time, right? So if I was able to do a time t, that means all the upper will be satisfied. Let's look it in other direction. If I was able to reduce a time h, this could be my potential answer. Whether I don't know whether in the previous one whether I will be able to reduce it or not able to reduce it. So this is a potential candidate for my answer. So that is what, if I was able to reduce at a given time t, that means my right will be mid. Okay, this could be still my potential answer. My range will still contain the mid, or else my left will be mid plus 1. In the end, left will be both will reach to a particular value where both values will be equal, and my answer will be lying at any one of those. Okay, let's now look at the good function. Okay, given a time t, we should be able to understand the what is the total height reduced by all the workers, right? If they were able to reduce the height which is greater than or equal to the mountain height, then they will be, then that's a happy case, right? So then the time t could be our potential answer. Now I'm just looping through each of the worker times, and I was trying to identify how much they can individually contribute to reduce the mountain height. Okay, let's say the k is the height which they can reduce, okay, for a given time t. Okay, so again this formula is same as this formula. Okay, in order to reduce it, in order to reduce the height h, this is the time taken, right? Okay, in order to reduce the height h, this is the time taken. So in order to reduce the height t, height k, so this will be the time taken, right? In a given time t, if I am reducing height k, so this should hold true. So if I solve this problem where w is basically the time taken for the ith worker, okay, so if if I write it over here, then you should be able to relate it, where w is basically the times of I, and this is basically the this one, okay, height times height plus 1 divided by 2, where here the height is basically k. So the ith worker is taking able to reduce k height in time t. Okay, now if you solve this equation, this will turn out to be this particular thing. Okay, so now I need to identify a value k. If you see, this is a quadratic equation, okay, in this particular form, ax square plus bx plus c equal to 0. Now what could be the value of x? X has two values, either it could be minus b plus square root of b square minus 4ac divided by 2, or minus b minus this particular value. Okay, if you see in our case, b is basically 1. Okay, so this is minus 1 and minus of certain value. So we are not looking to reduce the height in a negative value, right? We are looking for a value of k which is in positive, right? So this itself is not a potential answer for me, and this is only the potential answer, right? So that is what I am doing. Okay, so the k value will be minus b plus square root of b square minus 4ac divided by 2. Okay, so that is what I have written over here. Okay, I have just defined x as basically this value, okay, 2 times t divided by 2, and k will be, which is actually x here, this particular value. Okay, now that you understood the height taken, the time taken, the height reduced in time t, so I will be basically accumulating the overall heights reduced by all the workers. Okay, at any given point, if they were able to reduce the height equal to h or greater than that, then I will straight away return true, or else I will return false. Okay, so if you submit this problem, all the test cases will be passed, and it is pretty efficient solution as well. Okay, since we are applying just binary search, and if you see, we are just looping through this range. Okay, so this will take log n, where n is the range in which we are trying to search. And if you see the good function is iterating through all the times. Okay, so this will take big O of the length of the times. The overall time complexity will be big O of length of times logins. Okay, that is the time complexity, and there is no space complexity because we are not using any extra space. Space complexity will be big O of 1. Okay, I will be posting solution in multiple languages such as Java, JavaScript, Python. Feel free to check it out if you are coming from any other languages. Okay, yeah, that's all about this problem. Hit the like button, hit the subscribe button, and also share your valuable feedback in the comment section. And there are few tips which from my end. Okay, so whenever you are solving binary search problems, you will notice that you have to be very clear about the boundaries. That is the first thing. Okay, and whenever you are, if you see the answer is in long, right, so for sure our range will also be in long. Okay, that is one hint. Okay, and whenever you are doing typecasting, make sure you are typecasting it properly from int to long. Okay, that is also a common mistake which most of the developers would do. Okay, so make sure you are defining your variables properly and typecasting your variables properly. Okay, thank you.